to the very first FIBO talk series. And today speaker is first myself, and the second one is Dr. Varsity, or Dr. Ja. Firstly, I would like to introduce myself. My name is Supachai from FIBO, or you can call me Su. Today, firstly, I'm going to talk about disassembly automation, which is the cognitive ability for disassembly some products. And after that, we move to Dr. Varsity to talk about like how brain thinks about like learning about brain. All right. So again, before I come into work at FIBO, I did my PhD in manufacturing and mechanical engineering in the University of New South Wales. And my topic is cognitive robotics for disassembly automation. Okay. Today I'm going to talk about like 20 minutes, and after that, all question or anything is welcome. All right. Thank you. Firstly, what I want to talk is about outline of this presentation. First, I'll give some introduction. Sorry, can you hear me like it's better? Okay. Firstly, I'll give some introduction of what is disassembly. And well, disassembly, maybe not everyone that is familiar with these keywords, but actually, disassembly is something like reversal of assembly. So assembly is put parts and things together to make products, right? But disassembly is other way around. So I'm gonna show you some critical problems and how important they are. Second thing, I'll go to system overviews, which is I could say is robotics system. And after that, we will talk about cognitive robotics, which is one of the artificial intelligence field that makes your robot system to be smarter and smarter. Okay, and after that, some experiment and some conclusion. Okay, firstly, I will talk about lifecycle engineering. Disassembly is actually one of the key steps in lifecycle engineering. For lifecycle engineering, it's actually entering these disciplines that we talk about, like the whole lifecycle of products. Okay. Firstly, we go to material stage. You can imagine like when we try to create some products or create something, we start from material stage. We will get some material from somewhere in the world or outside the world, or whatever. And after that, we put this material into manufacturing process. That manufacturing process has normally become it's happened in industry, for example. And after that, after the product has been manufactured, it will ship out to the suppliers and then go to the customer or consumer. Over here, we will talk about usage phase, which all the consumer use these products. And after that, what happened? After that, if the products go obsolete or broken, so it's going to be end of life stage, which you are going to throw away, right? So all this is lifecycle engineering. All here is lifecycle of the products that lifecycle engineering would take into account. So why we try to work on lifecycle engineering? Exactly, it's very simple. We try to make our world more sustainable. So this is triple bottom lines of three factors to make things sustainable. Or sustainability is one of the things that nowadays like people are working on, sustainable development and things like that. So what we are working on is we are working on toward sustainability. So sustainability have three factors. So firstly, we have to take environment aspect into account. And the second one we try to do is social aspect. And the last one is economic point of view. So for environment, everyone tries to be green, right? Right now, promote that, okay, that products become greener and greener, like greener production, or for example, cars become greener is less carbon emission. But at the same time, you should become green and cause some problem in society. It will not be a good idea, right? So you have to find some balance between all this. So now we come back to this one. Over here, there's a lot of research and development has been done in this phase, right? Or for material like mining, manufacturing. There's plenty of them, like in Thailand and even China, or of like manufacturing industry in the world. They're working on this, and usage is plenty of them. But for end of life, I think it's still be like quite new idea to close this life cycle. So when we come end of life, what's going to happen? For example, if you have your mobile phone and you use it for a couple of years and then you throw away, right? And that's it. But actually, now we try to get all the value that still remains in the products back into the loop and get the process more efficient. For example, if you go to see this diagram, firstly, okay, it's production, manufacturing, distribution, and use. And okay, after it's broken, there are actually okay, maybe right here, but it's going to be, you can do recycling, you can reuse the products, or you can remanufacturing. That's very good strategy to get all the value. Maybe just a partial value back to this loop, right? So if it's reused, it's probably the best way. Like for example, if you have your mobile phone, it's still functional, but you don't like it anymore, it's obsolete. You just give to your friend, and your friend still can use it for a couple more years. So it's perfectly fine, right? Every value is back. But what if some part is broken? You cannot use them as a whole, right? But you can take some part and reuse some components, for example. Or the second one is remanufacturing. This one you take it for products, but this the product should be more and more expensive. For example, car engine, and everyone knows Sengong, right? So Sengong is one of the best place for doing remanufacturing. Like you take the whole very old engine, car engine, and you take part, you clean up, you replace some broken part, and it's still functional. And most of the remanufacturing, if you do it right, your product is as good as new or even better. Okay, there's a lot of business cases that are very successful doing this. And next one is okay, recycling. Recycling is okay, we cannot use a whole product or remanufacturing is probably not good. So recycling is you try to recover the material, the value of material. Okay, recycling you can do like now it's pretty popular, right? There are no technique like recycling plastic, you can recycling metal, you can recycling paper or whatever. So that's why it's recycling. But you have to keep in mind that the value that we put into products while we're making it will be gone, because you will receive just the core value of the material. So okay, or after that, what happened if we cannot do either of them, like three of them is an option. So what we have to do is we have to go to incineration. Like at least we can get some energy back, right? Incineration is you burn it and get some energy. Okay, and this energy you can take this heat to whatever you want. Or the last thing we want to do is landfill with this. Okay, dump it and forget about it at all. So we try to ignore this one. But if you want to go to recycling or remanufacturing or reuse some components, what we need to do is we have to separate all the parts, right, of the products. Can you imagine like your iPhone, for example? How many components in your phone? Anyone guess? Anyone guess? Okay, this may be around 200 to 300 parts, including all electronics, all chips. Okay, so it's not so easy, right, to separate all the parts clear and clean. Okay, so that's why we are working on this problem we call disassembly. Okay, it's over here. But we still have two ways to separate this one, right? You can disassembly or you can shredding. Disassembly, you will get components like very nice like this, or even not really nice, but you can get something costly. You can get, okay, this is LCD screen, this is some metal part, this is keyboard where you can reuse, or some PCB board, or some other components you can still use it. But if you go to shred, it becomes like this. Right? You cannot even do anything about it, right? So this one, what you can do is just you throw this one to recycling industry, and that's it. Okay. But over here, you can imagine you can sell back your LCD screen for $10, for example, on eBay, and you can still get some money. Okay. Okay, this is some example of what disassembly I have right now. Disassembly actually right now is, I could say, is manual operation, or the best case is semi-automatics. We don't really have the full autonomous system for disassembly things. Why? Because it's really, really hard. It's not just about assembly. It's not really a reversal of assembly, where you get a lot of much more uncertainty on disassembly. Okay, so most of it are manual right now, and because of product complexity, that's really hard. Let's say everyone got a laptop, right? I don't think everyone in this room got identical laptop at all. So at least this room probably you get like 30 models of laptops. At 30 models, you got 30 different build material, 30 structure. Everything is all, a lot of them, and very complex as well. And then, this one is non-profit activity. Like while you disassembly, you cannot get anything unless you can sell it, right? So this one is pretty much good, like zero baht profit get from this one. And after that, what we need is we need some expensive skilled labor. Like in Thailand, probably alright. In Asian countries, alright. But in Germany, for example, you pay something like $40–50 per hour for disassembling something, which is probably you can sell it back for $10. Yeah. So this is not really feasible. Right? And here is one of the, I could say, pretty sad, like get some like these little girls while they want to show and this guy just disassembly these things manually. And this is really sad that the most economic way to disassemble printed keyboard, I found out one of my Chinese friends, he told me, go to pan fry and get some gold and some precious material, and that's it. So no one cares about who is disassembling. So it's pretty sad. Okay, so we come here. Can we automate disassembly? Again, it's become like very challenging problem. Right? Even people is pretty hard as well, but we can try to automate it. It's really, really hard because of you need something that very robust and flexible system to disassemble things, and uncertainty for that process. Even you have one similar identical model of products, no one knows what has been done on that product. For example, if I want to like unscrew just one screw, no one knows that probably someone put the glue in and you cannot take it out, or some head are broken. So 100 of possibility, right? Okay. So to become like that is very, very hard for robot to do it. And this one is pretty crucial is unpredictable volume of products return. No one knows that if I create $100 million, like $1 billion system today, no one knows that tomorrow that's going to be the products that my system can work. So there's nothing guaranteed about this. So that's why not many people is trying to invest to create this technology. Okay. So my problem is still here. Can we still automate it? There's a lot of challenging problem here. So based on my research, I try to disassemble, but try to make it more feasible. So we try to equip cognitive ability like what people have to disassemble. Right? Okay, if we look into people like human manual disassembly, what can happen? Okay, we don't really need instruction manual, right, for disassembly. I'm pretty sure if I give you some products like LCD screen, for example, if it gives you some like toolbox, a lot of tools like screwdriver, cutter, hammer, whatever, you can just try to figure out, okay, this is here, can you try this? Unscrew this one, it's not good, or we look for snap fit, and okay, you can still figure out sometimes, right? But probably take you an hour or whatever. But finally, I'm pretty sure you can. And what happened if you see the same products again, same product model? Probably it will not take you an hour, but it's taking you maybe 10 minutes, because you know already what's going to happen, and you know set of tools, set of actions, what happened if you do this or that. So we call this cognitive skill that human can learn about this as well. Okay, so here I try to emulate this action, this kind of action, this kind of mindset to my robot. Okay. So my robot is pretty like rough setup. So I could say it's probably the cheapest robot system ever. Okay. So I try to minimize everything, try to design in very cost-effective way. Like this is a small robot, and I equip it grinder here. So I just cut everything. To do like unscrew or something very costly, especially in robots or especially in robotics field or some mechanical system fields. You can imagine like the force feedback and everything that you need to get a screwdriver to just unscrew it. This is very hard actually. Okay, so what I try to do is I just put angle grinder, and that's it. Have everything. And have visual system for Connect. Just Connect, Microsoft Connect to get that image from this one. Okay. So cognitive ability. What is cognitive ability? It's actually autonomous robot that can deal with incomplete knowledge. So it's like artificial intelligence, right? But we also include some learning ability to learn and ability to reason and adapt to that world as well. This is some like definition of cognitive robotics. Okay, so we have vision system that can detect. So vision system is like our eye, right? So this one we perform some detection algorithm to detect. For example, this is principal board, and I try to automatically detect all the screw. And if it's find screw, it's just unscrew it. If you get the cable, just cut it, for example. For disassembly automation, I try to do this. I don't really give, firstly because this principal board will vary in every single model, right? So I cannot specify like very particular, but what I try to do is I just give the very broad rules. What we're gonna do if it finds. So firstly, we can localize this one. We can localize. Detect the circuit board, and then we just cut around. If it's cut around and cut all the screw This means usually you can do it to detach, but like the circuit board normally is fixed by screws for this four, and the cable, some cable that connected. So if you detach all the cables and unscrew it, you can remove it. Right? So if you try this and good, that's fine. But if it doesn't, what's gonna happen? I try to looking for more things like try to look for cables and connectors and try to destroy it. And still it doesn't work. Okay, you try to cut over here. Because I found that 90% of screw could be very close to water. So I just try to cut it. And if it doesn't work, I try to cut more. So at least I should have this part detached, but this extra part detached. But by the way, if this one still doesn't work, this robot will talk to you then, okay? Give me some help. Alright. Okay. Because what happened here? You see this one? This connector is really a very small rivet. It's like 1 millimeter, and the camera cannot detect at all. Cannot even try to detect, it's too small. But real equipment is quite easy to indicate, right? So it's here. So robot just cut here, and that's it. So this one should be removed. Okay. And this is kind of just space for disassembly. So firstly, my product to disassemble is LCD screens that I try with something like 27 models, all different models. Okay. And usually they have like these 5 components, but the sequence of disassembly are all different, like this one. This one is the summarize of what I have disassembled. Okay, so this is a space, and we can go one by one until you reach the goal with everything is separate. Okay, and each point is actually a variation of operation you can do, right? That you can cut first, you can unscrew first, or you can get the cable detached first, and a lot of variation here. So over here, if you're quite familiar with artificial intelligence, it's all about this. You go through the search space and room through and try to find the problem, try to reach a goal, right? But over here is something more challenging, because sometimes if you cut, if you get some action done, and you just realize that, okay, this is not good action. If you want to go back, like retract to the previous one, alright, you can retract virtually, but not physically, because it's already cut. Okay, so this is one of the challenging problems as well. Okay, come to behavior control of my robot. So firstly, start. This one is trying to what we are doing as a human being, right? Okay. If you look into the products, okay, I know this product or not, maybe not. Okay, go this one. Try to operate kind of like that, like I go to reason about that, and try until it's success. If it's success, okay, then try to detect one component, right? Each component, and remove it one by one. Remove physical board, remove LCD models, remove the cover, whatever. And then you fix one by one, and after that you learn something. Okay. And after that, if you go again and you see the same products, you go, okay, I know this model, I've done it before. So what you have to do is you have to just follow what we already learned, right? So this one maybe like take this action trigger. Okay. And we also have the revision. If we find out that okay, the product is the same, but something wrong with this product, we should be able to learn as well. Get some exception. That next time you will realize that okay, this model probably you need to concern about little fixed point, for example. Then after that, what I found out was, okay, this one had a result. Firstly, you have this, and the robot just cut around and you get this PCB cover. Then you go to trim all the PCB boards here, and cut around, remove also the board, and you see the carrier and so on. This is some of the experiment, and this is quite interesting. Firstly, try to disassemble all 40 different models, and you get something like around 40 to 60 minutes per model. Okay, with performance. But the most interesting thing is this one, because it's learning. You can see that okay, the time for disassembly is getting lower and lower. So this is very first time my robot disassembled this model, and the second time you can see that the time is lower from 50 minutes to 40 minutes, and after 5 times maybe can done in 30 minutes. And this is another sample model. It starts from 60, and finally we can get down to something like 25 minutes. Okay, this is how my robot learned. So before we go to finish my part, I'll show you some my video to what is really happening. That's right. Try it. Okay. So it's just cut, and after cutting, the working table is flipped. So if something that has been touched, will go down, will like drop down, right? If it doesn't, it means this action is still not good. So he try another action. Okay. And something happened like this one. It's cut and it's almost gone, but still cannot figure out like how to do it. Okay. 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 Move forward, and if you're interested in this video, you can YouTube with my name and you can find it. All right. Okay. So come to conclusion. What I found out from my research is okay. We try to make the robotic system that can automated disassemble stuff. But this one is one of like little starting point. So if you try, if you have like better system, if you have better like strategy or solution, we can try to give more cognitive ability to the system to achieve our goal in more efficient way and faster and faster. And finally, I hope that in the future we can make disassembly more economically feasible. So everyone can try to get into disassembly and recreate our world more sustainable. Okay, and some of the publication that this series that talking about my research. Okay, thank you very much. And if you have any question, we have maybe a couple of minutes before we move to our next speaker. Okay, thank you. Any question?
So how does the learning work again?
Oh, just this one is pretty simple. It's pretty simple. It's like it's record in a database. It's like the first time. So we record the operation, right? So if you go back to this one, what I learned is, sorry, not I learned, but what the robots learn is the components and this action, the operation, to get that components out, right? So you can learn that, okay, the component number one, you use this plan with some parameters. Okay, with the parameters, for example, this one parameters could be the distance between the distance from this edge through the cutting line, for example, and the depth of cut as well. Okay, then you learn the plan, you learn parameters and all this for each component. So over here, for removing this one, you know that okay, this one is the back cover that belongs to model ABCD Samsung, for example, and that one for this component you have to use plan A, B, and C with these parameters to complete these steps. So all these are recorded to database, and that's it. And after that, it says we call this from the database, and just use it straight away.
So does the robot get the information from the previous piece that come from the same model?
Yes.
Yeah. So it know that last time with this model,
Yep.
I did this, and I'm gonna improve. But does it know how to measure the time? Like one of the
Okay, we have
cars?
this long story, so we have to go on here. It's part of revision. It's part of revision that for the first time and second time, it actually has an algorithm to figure out that okay, probably the first time I use all plan 0, 1, 2, 3, right, and finish it. But second time, it's not that okay. We have to complete. We have to use the robot has to use these 4 actions. But probably this one can be change the order. So probably next time is just go to plan 3, 2, 1, 0. Something that has to swap all the orders.
So it has some kind of exploration.
Yep. But it's happened in like different time. It's not just one piece of model, but the same models with different. So that's why if this goes through this 4 and in different order, it can figure out that later that okay, probably this one you need just like plan 3 and 1 and can detach it. So that means you save some time for doing plan 0 and 2. Right? Okay, that is kind of revision, and that's why it's come to this one. Over here, some time decreases for some operation has been gone. Okay, let's just remove that operation. But in the future, I have one of my students still working in functional robotics in University of New South Wales. Well, she tried to work on okay, how can we learn and get better result by not just from the same model, but for example, little robot working on model 1, 2, 3, and is it possible to learn from 1, 2, 3 these 3 models and propagate his discovery to the 4th model? but still very, very hard problem. So you need for deep learning